Hi, in this video I will summarize chapter 17. This is the final video and this is the final chapter in this book. This chapter is all about code smells and heuristics. Overall, this chapter tries to summarize the entire book, and we'll see how all of the previous chapters, some of the best practices are covered in this chapter. So the first section about code smells and heuristics. And again, this entire chapter is, and the book itself is around craftsmanship. How do we get better at our craft? And various chapters, one by one, dealt with comments, functions, syntax, naming, and we'll go through each of these. The first summary is around comments. How we should use comments wisely and put in information in comments that is appropriate and not inappropriate information. Comments should typically have the reason for why this function exists. What was the logic decision making process? What is it that's hard to convey that the user cannot read just by reading the code? So that's the best use of comments. And so we should absolutely avoid putting in obsolete information in comments. So just delete obsolete code, obsolete comments. And redundant comments, which is just basically naming the name of the method, the parameter names, and not really adding any value, shouldn't be there. Like, you can read the method name and parameters. You don't need comments to just name all of them. Poorly written comments where you don't really think through what you want to convey. Grammar is not right, spelling mistakes, it's bad. So write in a good way. And finally, if there are comments that are commented out, then remove them. So that's comments. Second is about having an development environment where you can build the entire system, check out the code, build it, typically in one command. So it's easy, or one shell script, or in a very simple way. Similarly, same for tests. You should have systems where you can easily and quickly run all of the tests with one command or one button push. Making it convenient so that these systems are tested frequently. And the test should run fast. Third section is about functions, where there are a lot of best practices. There's a whole chapter devoted to functions, but 3 or 4 main points here is around how do you choose function names, how do you make sure that they have the right set of arguments. More than 2 arguments, you should really be skeptic about that function. Ideally is 1 argument, or even better is no argument, but 3 or more, you should think really hard. Avoid output arguments. You should change the state of the function, state of the object, which the function is being called on instead. Boolean arguments, avoid it. It's very hard if you have arguments that dictate code path within functions. It's going to be hard for you to keep that argument in mind and think through both use cases. So avoid Boolean arguments. Dead functions, which are commented or not used, should be deleted. Finally, Java. Some of the key things mentioned here around how do you deal with wildcard imports versus individual imports. There's a lot of discussion around this, with author recommends using wildcard imports to keep it easy for readability. Use of enums, especially after Java 5, is encouraged instead of static final constants that developers used to do before. So that is a few tips from Java, but I'd say read an entire book recently around the latest Java best practices and the latest features, and get familiar with this. Names, there's an entire chapter here, but choosing descriptive names that will make your code 90% readable, meaning the 90% of your code readability is based on your naming. How do you name your variables? How do you name your functions? Do not use magic variables like x2, f1, q1, q2. So it's hard to understand what they mean. So use good names. Provide inline description, comments of your code that you're writing. when you think it's going to be hard to just understand directly from reading the code. Also, choose names at the appropriate level of abstraction. So when you name a class, make sure, depending on the type of the class, the name is used correctly. If it is not an implementation, do not name the class name as an implementation. It would be hard to understand what the class does. Abstract class name versus implemented class names would have different names. And interfaces that don't do anything should have appropriate names as well. Then it's about using standard nomenclature when possible. So for example, when you're using toString, it is a very known method. So when you use it, make sure it's actually converting it to string. Otherwise, don't use it and call it toString. If you're not using an established pattern like decoration pattern, then don't call it that. Do not confuse it. Use the standard nomenclature and actually mean to use it. Use unambiguous names, clear intention as to what the method is, what the variable is highly encouraged. Using long names is you can lean more over that versus short names, especially when you have the scope to be much larger. Avoid encoding a lot of like prefixes like L1, L2, F underscore, G underscore. Do not encode prefix or suffix to your names. And names should describe side effects if there are any. Like if you're doing something and something, then name it that way. So name is very, very important. Huge contribution to the readability of your code. Tests, this is a big important part. Tests, you should test thoroughly. You should have a tool that tests your coverage over time. Monitor that. You should have sufficient amount of tests. You should not skip trivial tests. And ignore test is just saying that there is some ambiguity for the developer. So do not ignore test. Make sure you revisit those tests. Test for boundary conditions. Exhaustively test when you see bugs. Test around that area of code. You will see more code bugs around that area. And when you add some functionality and you don't know why it's failing, why the tests are failing, you can see certain patterns of test failures and you can make out what the issue is with your code. So patterns of failures are also revealing. The biggest tip for tests is that tests should run fast. That's it. If you want developers to run your tests, then they should run fast. If not, they will not be run. They should run not only fast, they should run reliably. And that is I think the single most important tip. You should be able to run tests fast and reliably. So that's tests. And then the final section is like 30 bullet points here, which are general craftsmanship guidelines, and the author is trying to make sure that he doesn't he wants to repeat it so that it goes into our brains. Some of these I'll go over quickly, making sure we use only one language in one source file instead of multiple, like HTML comments and then Java code and some other scripts inside. So one language per source file. And then make sure that the name of the function that you have or the class name that you have is that method, function name, or that class actually implements what is intended. So implement the obvious behavior. Make sure that the user, whatever the user would assume, is what they get. So less surprises. Test for boundary conditions. We checked for that, but we should check for behavior under boundary conditions. And if we override safeties, we know we are in the wrong footing. So be very, very careful when you override settings, when the method actually tells you not to use in certain way, but you use it or you set certain flags. It's bound to fail at some point in time. So very, very careful when you explicitly override safeties in your code. Avoid duplication in your code as much as possible. It's the starting point where everything gets harder to maintain. So take time to refactor your code to avoid duplication all the time. And code at the right level of abstraction. So that'll encourage for code that is much more encapsulated, uses the best practices of object-oriented design principles. And then ensure your base class don't have dependency on your derived class. They should not know anything about them. And then too much information in one method or one class is typically calls for refactoring. If there's a lot of dead code in your functions or class, they should be removed. And then vertical separation is very important for the person to be able to read your code. In the vertical separation is so that you're using the screen size in such a way that you can read the code reliably one function after the second. And equally important is horizontal separation. You don't want them to scroll horizontally a lot, typically never. And so the other point is around inconsistency. Do not have inconsistency on how you name, on how you implement, how you structure your code. Follow patterns that you establish within your team. So another piece is artificial coupling. So due to convenience, we place certain methods where they shouldn't be placed. So do not do that. Put functions and classes in the right place. Feature envy is when we have one method knowing too much information about the other objects methods and going too level deep. So just one level deep. We covered in one of the previous chapters, law of Dimitri. Selector arguments, when you have pass-in Boolean arguments that says, choose this piece of code versus the second piece of code. Avoid that. Obscured intent versus expressive code. So if you write certain things that you can understand really well because you wrote it, but no one else can understand it, avoid it. It's bad. Very soon you will forget and no one else will know. So write expressive code instead. Do not use static methods inappropriately. Think carefully. Do you expect that method to behave polymorphically? Does it operate on the object that is passed to it or other objects? Right? Think hard how and when you use static. Use explanatory variable names and also function names and class names, as we just covered. A whole section around naming. It's huge. The other point here is understanding the algorithm. Like, you should really know what your algorithm is. What do you expect your function to do? If you don't understand it, take the time to understand the algorithm and then implement it. Prefer polymorphism to if-else and switch cases. Typically only one switch, and even within it's just creating polymorphic objects. Keep it dry. Keep it dry as in do not have duplication. And single responsibility principle, where you have one method actually doing one thing. Be precise. Do not use verbose code where you don't have to. Use the right level of judgment. Structure over convention. Switch cases with nicely named enumeration versus base classes that enforce concrete classes have abstract method implementation is much more preferable. So prefer structure over convention, because conventions people can ignore or forget, but structure is enforced, right? Avoid negative conditions. It's already hard within to write if not function not x, right? So avoid negative conditions. Make it easy to read. Functions should do one thing. We talked about that multiple times. Don't be arbitrary when you write certain piece of code. Don't be arbitrary. Be precise as to why you're writing it and have the exact reason in mind, and place the right things at the right place. Do not arbitrarily just put any method anywhere. Encapsulate and test boundary conditions, very important. Functions should descend only one level of abstraction. Again, law of Dimitri. Keeping configuration data at the high level will help you to change those configuration at any time without your downstream classes having to change or know about it. And avoid transitive navigation. Again, this is law of Dimitri. So that brings to the end of this chapter. Overall, this whole book was around craftsmanship. There's a lot to read for the beginner who's getting into, or even for someone who's developed code for multiple years, to learn from some of these principles that are outlined in this book. Highly encourage you to read this book. I hope you found this useful. Thank you.